All right, I'm going to talk to you really quickly about solving systems of linear inequalities. And this is very similar to solving systems of equations, and as well as graphing linear inequalities. It's just a combination of the two. So the first one is negative 3x plus 2y is greater than or equal to 2. And then we also have y is less than 4x plus 3. So over here with the solid line, and I know it's hard to see, and again, I apologize. My computer's messed up with recording, so this is the best way I could record this for you guys to review for your quiz and test, okay? So over here, this solid line, and the reason it's solid is because of this greater than or equal to part. So I graphed it the same way that I would graph an equation, but because it's an inequality, I have to shade because there's more than one solution. Or there's not just the line of solutions, there's all these other areas on the coordinate plane that are also solutions. So I shaded that in yellow. Then I graphed this other inequality, y is less than 4x plus 3, and that's shown by the dotted line because it's not equal to, that's why there's a dotted line here, or a dashed line, and then I shaded all their solutions in green. Well, because this is a system and the two go together, the solution to the system is the parts where these two graphs overlap. So I covered that again in red just so that it could really stand out. So all this part in red is the solution to the system. The yellow is the solution to the top one, the green is the solution to the bottom one, but the red is the solution to both of them together. So it's the solution to the system. Now, something I may ask you is to give me a possible coordinate of a solution to the system, and that would be just you picking out any point that's in that area. Don't pick anything super close. I mean, make sure that it's really obvious, you know, that it's in the middle, that you can tell. So an example would be 3, 7 is a solution to this system. So if I went back and I plugged 3 in for x and 7 in for y, it would work for the top inequality as well as for the bottom inequality. Okay? All right, so let me show you another example. Over here in the yellow part, we have y is less than or equal to x plus 1. Again, it's a solid line, and I'm erasing it as I'm talking. It is a solid line. And this whole area is the solution to that inequality. Then I graphed y is greater than 2. It's a dashed line because it's greater than, and I colored that area in green. The overlapping area is what is right here in red. So this red area is the solution to the system of the two of them together. And again, a coordinate that would satisfy both of these inequalities would be 4, 4 because it lies in this red shaded area. The last example that I'm going to give you is these two lines, or these two inequalities. When you graph them, they are parallel. Over here in the yellow, we have the first one. This is y is less than or equal to negative 2x minus 4. Then over here with the dashed line, we have y is greater than negative 2x plus 5, and that's shaded with the green over here. I don't want you to mistake and think that because these two lines are parallel, or these two inequalities are parallel, that it's automatically no solution. That's not going to be the case with all parallel graphed inequalities, because the solution is where the two overlap. Now, it just so happens that these two do not overlap. So there is no solution to this inequality because there's no overlapping. There's no part that I colored red. However, if this particular one right here had just been changed where it said y is greater than or equal to negative 2x plus 4, then all of this over here would have been shaded, and then there would have been some overlapping. So with inequalities, it's the direction of the arrows that really make a difference to the solution. So I just want you to be very clear about that. Okay?